Hello everybody, welcome to the Python course. In the previous part we have covered introduction to matplotlib. In this part we will cover the Seaborn library. In the previous lecture we have seen how we can create simple plots in matplotlib. We have seen basic scatter plot, box plot and histogram. In the Seaborn also we will see the similar structure, how we can create the scatter plot, histogram, bar plots and Whisker plot. So let's get started. I have already opened up my Anaconda navigator and has navigated to module 13, that is Seaborn, and I have my data ready to get into the pre-processing part. So I have already read the Toyota.csv dataset into my pandas data frame object, and I have processed the junk values to NA values. Then I have dropped all the NA values using my drop NA function. Then I have displaced using the top 5 entries using my data.head command, right? So let's now see what is our SNS library, right? So in the previous part we have learned how to create basic plots using your matplot library. We have seen scatter plots, histogram and your bar plots. Now in this lecture we will see how we can do the same using our Seaborn library. So let's understand what is a Seaborn library. So Seaborn is a Python data visualization library based on matplotlib, right? So the basics of the Seaborn library is your data visualization library. So whether you can use your matplot library or your Seaborn, the only difference is that Seaborn provides you a high level interface for drawing attractive and informative statistical graphics, right? For a beginner you can start your visualization part using your matplotlib, and then you can move to your Seaborn library. The basic command and basic logics remains the same in both these libraries, but Seaborn provides you some interactive graphical interpretation or interface so that you can show it to your clients or your end customers. Let's try to create one scatter plot. So we have already imported all these libraries. So we have imported pandas as PD, numpy as np, right, and matplotlib.pyplot as plt in the previous lecture. Now in this lecture we will import our Seaborn library as SNS. So Seaborn and matplotlib are used for the visualizations. Numpy is used for numerical computations, and pandas are used to convert your data sets into your pandas data frame objects. So let's import this. So we have already imported this and we have already pre-processed our data and removed the missing values from the data structure, right? Then we wanted to plot the graph between the price and the age. So these are the basically two independent variables, and we wanted to find the relationship between those two independent variables. So previously we have seen how we can do this by using the scatter command, scatter plot in your matplotlib. Here the basic command is your regression plot, because it gives you the relationship between your two independent variables, and here two independent variables are your age and your price. And by default your fit underscore regression, that is the line representing this regression plot, is true, right? If you set it false, so this line will be disappeared from your graph. And you can also set the style of your graph. So there are various styles. You can look up it in the official documentation of Seaborn, and there are many styles which you can refer with, and you can change the style and you can find out the different graphs using this styles, right? So here in this, so we have the dark grid in which the grid appears, right? So let's get into action. and practice this one, right? So we have already imported our Seaborn library as SNS and imported all the necessary libraries to work with our data set. So SNS dot reg plot, in which I will say data, age, and I wanted to find the relationship between price and data is my data set, right? So this is my basic plot, in which this gives me the relationship between my age variable and my price variable, and as you can see that as the age progresses the price decreases, right? So this is your negative, right? The line is moving your downward trend, right? If it is going upwards, then you can say that your it has got a positive correlation. So the relationship between the variables is your positive one, right? Similarly, you can also set the styling part, SNS dot set, and you can set your style equal to dark grid, right? Okay, so this is your basic plot, and if you wanted to have your regression fit underscore regression line to be set to false, then this line will not appear in your graph, right? Okay, right? So this I have already shown you. So if you do it fit underscore regression as false, this line will not appear in your graph, right? If it is by default it is true, and it will appear. Okay. So the next part is your histogram. So histogram gives you the distribution of your variables, right? Right. So basically we wanted to see that if we wanted to see the age, like how many cars are there of a particular age ranging from so and so. So as you can see in this graph, so car in the data set, the age of the car, which is ranging from 60 to 80, has the highest distribution, right? Almost all the cars are between ranging from 60 to 80%, 60 to 80 years, right? Right, age is 60 to 80, right? So we can plot this plot, and we can get the variable, right? A single variable has to be included because it gives the frequency count. So I would say SNS dot dist plot, and I would say data, then age, right? So this looks pretty fine with us because the bins are sorted, and we do not have to separate it by using a white line, in case we have previously done in our matplotlib lecture, right? With a single line of code you can plot your dist plot, right? So this is very much effective, and it gives us better representation as compared to your matplotlib, right? Okay, so if we don't want the kernel density estimate, we can set it to false, and this is usually being done to represent your distribution, that in what kind of distribution this graph is having. So that's why, so if you want to set this, then kernel density is set to false, so you can set it to false, and now that part has been disappeared, right? Okay. Okay, so also we can also separate it by using your bins. So we can have fixed number of bins. So by doing this, we can also take the bin size as equal to 5, right? In which, so you get a bin size, so your data has been segregated into these 5 bins, right? So this way also you could set your data structure according to the bins, in which we get the bars, right, in which gives you the frequency count of your data of the x variable which has been put it in your dist plot. right? Okay. So the next is bar plot. So the bar plot gives you the frequency distribution of the categorical variable. For example, you wanted to check the fuel types, right? So how many count or how many distribution of the how many number of cars are there of the diesel, of the petrol, of the CNG, that is the according to the fuel type I wanted to know the distribution, right, or the frequency count. So that could be done by using your count plot. But one thing to remember, the fuel type must be a categorical variable, right? So for the numerical variable there is your histogram, and for the categorical variable you are having your count plot. So this is done using your count plot, that SNS dot count, and we have the count plot. In the data we have your fuel type, right, and data is equal to data. Now the data has been already been segregated according to the fuel type. Here no need to give the indexes and values and then you can plot it. So by the use of the count plot, it automatically sort the data according to number of values which are present in your fuel type, right? So it has automatically segregate out 3 values and it is giving us the distribution of it, right? So this is how you can plot the bar plot, right? And if you wanted to group the bar plot according to the hue factor, so what is this hue factor? You wanted to also check how many cars are there according to the fuel type, and also I wanted to segregate out how many cars are there for the manual and the automatic. Based on the manual and the automatic, I wanted to segregate out. So it says for the petrol you have automatic cars ranging more than 800, and for the one is for your 0 is for your like manual, and 1 is for the automatic, right? So the automatic having 1, so you can have like less than 200 cars, right? So this is how you can get the distribution according to a third variable. So that variable must be also be a categorical part, so that cannot have a numerical part, right? So it can have, but the graph, it will not results you in correct format, right? The numerical data would be so large that it couldn't be represented in your graph. So better make sure that hue factor is your categorical part, right? So here if we wanted to plot according to the hue factor, that is your automatic, that also we can represent it, and now you can see that so your data has been represented according to the fuel types and also according to the automatic, that is 0 and 1, right? So this is known as your grouped bar plot. Now we'll cover the last part of this lecture, that is box and whisker plot. So these are very useful, right? So it gives the 5 number summary, right? So for example, in this graph we have plotted the price variable in the box plot, right? So and here we could see that the lowest range is below 5,000 and 25 percentile is around close to 8,000, right? And in the 10,000 is your median, this is your 50 percentile, and this is your 75 percentile range, and this is your maximum value, and after maximum value these are your outliers. You can see that by graphical representation of the data you can see that price variable has got some kind of outliers. So generally your data should reside in this block of code, that is in this box, right? And after that whatever it resides, so these all points are known as your anomalies, right? So it is very useful in finding out the anomalies of your variables, right? So let us try to practice this. So SNS dot box plot, and if I try to see data and of price, right? So here x is equal to, okay, so now it is correct. So if you so this is difficult, like other way representation. If you plot it using your x, so then you can put it in the x axis, and if you wanted to go into the y axis, then you can put it in the y axis, right? So this represents your minimum value, then you have your 50 percentile, 25 percentile, 75 percentile, and you have your highest value. This is your minimum, this is your highest, this is your 25 percentile, this is your 50 percentile, the middle one. The 50 percentile is your median, right? And after that, all these points are your outliers, right? So this is how you represent your box and whisker plot. Also, if you wanted to plot it according to your fuel type and your price, so that way also you could represent, right? For the numerical versus your categorical variable. So your fuel type is your numerical, and your price is your your fuel type is your categorical, and your price is your numerical variable. So you wanted to check according to your fuel type what all prices are there and how the prices varies according to your fuel type. So in the x-axis we have your fuel types. This is your fuel types, and in the y-axis you have your prices, right? So here in this similar part we could also represent SNS dot box plot. In the x-axis we have your fuel type, and in the y you have your price, right? And your, okay, so now you can see that. So in the CNG you don't have any outliers, but in the fuel type, that is petrol, so you have some outliers, but in the diesel you have the some of the outliers which are way high than your normal range, right? So these outliers can be removed according to your business need. So we can say that we can have the outliers up to 25,000, but after 25,000 we are not permitting any kind of outlier, so that data should be faulty or that is anomaly, so that has to be removed, so that we can judge or we can interpret our data set and likewise do the modifications, right? So based on this we can say that this is the best method to choose how to choose the anomaly, right? So then we have the grouped box and whiskers. So if you put a hue factor along with it, so that becomes a grouped box and whisker plots, right? So here in this case, if I put a hue factor to it and I wanted to check how many cars AU automatic, okay, so according to this, so this is automatic, so right, so this has got the orange part also, right? So here in this part, earlier part, we were having the petrol variant combined together as one, because it doesn't both the automatic and the manual has been combined into one part, right? But if we wanted to categorize into separate parts and we wanted to check the outliers, so here is we can represent it by using your hue, right? And then we could make the necessary modifications according to our data, right? Okay, so now we have learned how to create the basic plots using your Seaborn library. We have seen our scatter plots, histograms, and bar plot and grouped bar plot also. Then we have seen box and whisker plots and grouped box and whisker plot also, right? So this is how we do the visualizations in your Seaborn library. Okay, so thank you guys, thanks for watching.